Okay. So what if it's turned like this? Say this is at a 55-degree angle. The angle in between these, well, it would have to be 55 degrees. Then how much torque is being applied?
So where's the center?
Right here.
And you're pushing on that.
Pushing right here.
Okay. So why does the angle in the middle matter?
Well, it doesn't necessarily.
Okay.
Well, it would if you, so say you're given this, maybe there's something pulling, like hanging on the end of this, maybe a rope that's pulling down, and it's just pulling straight down, and this is like the lever arm is being pulled down and it's at 55 degrees. You want to find out how much torque is being applied. So you wouldn't necessarily know, you just know that this was vertical and this was 55 degrees from the vertical. Then you'd have to find out that this angle is 55 degrees. Okay.
Okay. So this time we're going to have to use sine again. 10 sine 55 times 5.
Okay. So that'd be right. Okay. So there's a couple ways. If you look at it this way too, what would this distance be? From here to here.
I don't know how to find that.
So you've got your hypotenuse here, and then 55 degrees. So it'd be 5 sine of 55.
Okay.
And now, if you use that as your lever arm, now your force is perpendicular, right? So you could basically move that up. You could say this is 5 sine 55 with a force of 10 newtons, because vectors can be moved around as long as you don't move it this way. But anyway, so this is the line of action of the force. This is what that's called. So as long as if you draw a line from the middle straight out to the line of action, so it's perpendicular, then you can use that too. So either you break down, so you can think about it this way. Let's see, maybe we've got something like this. Either you break down the force and you find this would be the force times the sine of phi. Okay, and you find it that way. Or you take the line of action of the force and you draw a line perpendicular to it. And you use that as your L, actually let's call it R sine phi. R sine of phi. So either you can break down your force so that it's perpendicular to the moment arm, or you can break down your moment arm so that it's perpendicular to the force. But either way, it's just going to be RF sine of phi. Okay. So torque's pretty straightforward. So that would mean no, I'm not gonna, it's not gonna. And then you can sum it just like you can sum forces. Does that make sense?
Yeah.
So let's say you've got the door.
So again, we would be doing free body diagrams.
Yeah. Except in this case, your free body diagrams have to be long
Okay.
to show the length, right? So let's say somebody is pushing on this door this way with, say, 6 newtons worth of force. Somebody else is pushing on it. They're kind of coming at an angle. This is 40 degrees. And they're pushing at 15 newtons. Which way is the door ultimately going to swing? Oh, and the door is, say, 2 meters wide. And this one is right in the middle. Let's see. 1 meter. 1 meter. So which way is the door going to swing?
So we're going to use 15 sine 40.
That would be going this way.
Well, so that would be going, or no, 15 sine 50, right?
It's always the angle between the two of them, right? Because we want this,
Yeah.
this one, and these two angles are the same. This one's 40 degrees, right?
Okay, so we can't say that this angle is 50 since this whole thing would be 90, right?
You can say it's 50, but then would you use the sine or the cosine to get this piece?
Cosine?
Yeah. So you can switch the angle and use the cosine.